Hello, dear students. Welcome to the Unacademy. So, I hope all of you are fine, and all of you know that this is the second marathon series of complexity theory. That one part one already I have covered in my previous lectures. You can search on the YouTube that the complexity theory part one, and this is just a part two. So, am I audible to all of you? Please respond me as soon as possible. Am I audible? Okay, my dear friends, let's crack GATE ESE with India's largest online learning platform. Get the Plus subscription now and start your preparation with India's best educator with unlimited live and recorded video lectures. Myself, Ajay Das. I am MTech in Computer Science. I have a 8 plus year of teaching experience, and till now I have trained almost 20,000 plus engineering students for the GATE and PSU, and also work as a freelancer in many reputed institutes of India. Also qualified the GATE exam 5 times below the AIR 500, and apart from that the qualified the Chhattisgarh State Electricity Board exam with AIR 8. So download the Unacademy learning app and start your preparation right now, right here. So my dear friends, what you will get? This is the major question which always used to arise whenever a student wish to take the subscription, or you can say the admission in any online learning platform. So first thing, you are going to have a daily life classes. The second one is the structure courses. Third one is the live test and quizzes, and of course unlimited access. You can access the lectures again and again until you get the entire concept. This is our motto. So learn with the top educated. This is the weapon of Unacademy, you can say. So Unacademy is offering you, as I told you, India's best educators. Means no compromise in quality. So my dear friends, now you can imagine, if no compromise in quality, then no compromise in result. So I have described only few of the educators who are associated in Unacademy for GATE and ESE. If you want to know more about the educators, what you can do, you can just download the Unacademy learning app and you can check the profile of each and every educator before taking the subscriptions. Okay, so Unacademy offering various branches under the GATE and ESE courses. So you can see over here like computer science, IT, or mechanical, or electrical, civil, production engineering, instrumentation, and chemical. So these are the branches which the Unacademy is offering you for the preparation of GATE and ESE. So according to your branch, you can take the subscription in any one of the branches. Means according to your branch, you can take the simply a subscription. But if you want to take the subscription, never forget to use the code IFA. So this is the code which you can apply while taking the subscription. My dear friends, let's say if you are taking a subscription of the 12 month, then your fee structure will be 30,250, and this fee structure is applicable under the subscription of Plus. Now recently the Unacademy has launched the new kind of subscription that is known as Iconic. So this is the already coming from the last few years, and this is the new subscription model which is the Iconic. So if you are taking a subscription in a Plus, then the fee structure for the 12 month is this, the fee structure for the 18 month is this, and the fee structure for the 24 month is this. अब आपके जहन में एक सवाल उठ रहा होगा कि सर ये सब आइकन प्लस का सब्सक्रिप्शन फीस है, तो आइकनिक का क्या होगा? क्या आइकनिक में 1 मंथ 3 मंथ के कोर्सेज अवेलेबल है? So we will see. So my dear friend, these are the actual fees for the Plus subscription month wise, but once you will apply the code IFA, you will immediately get the minimum 10% discount. So these are the discounted fees for the 12 month. This is the discounted fees for the 18 month, and similarly 24 months. So all these are the discounted fees for 12 month, 18 month, and 24 month, and these are comes under the Plus subscription. Now let's talk about the Iconic. So my dear friends, of course the name itself says something, that it contains some additional features in comparison to the Plus subscription. So if you wish to take the subscription in the Iconic, there are only two subscription model available. Either you can go for the 12 month or you can go for the 24 month. If you are taking a subscription for the 12 month, then your fee structure will be this. And if you are taking a subscription for the 24 month, your fee structure will be this. Again, in both the condition, if you will apply the code IFA, you will immediately get minimum 10% discount. Got it? So let's see what is the difference between Plus and Iconic. Plus and Iconic. So my dear friends, in the Plus subscription, you can have India's best educator. Of course, either you are taking the Plus or Iconic, you will get these things for sure. So second thing is the interactive live session, structured courses and PDF, live test and quizzes. So whatever the things you are getting in the Plus, definitely you will get in the Iconic also. But what is the additional things you are getting in Iconic? Because you can see the fee structure of the Iconic is little bit high in comparison to the Plus. Okay, so the personal coach, you can select any one of the educator as your personal coach who will guide you, who will motivate you, or who will clear your doubt time to time, so that you can improve the performance, your performance, and finally your target could be achieved. The second thing is the personalized test analysis and the study planner, and finally the study material. So these are the extra things which you are getting whenever you are taking the subscription in Iconic. Got it? And that's why there is a difference of little bit difference of the fee structure between the Plus and Iconic. So now let's start the subject. Let's crack it. So my dear friends, in the previous session already I have deal with the substitution method. I hope you remember substitution method. And as I told you that any recurrence relation can be solved by three different methods. Any recurrence relation can be solved by the three different methods. First one is the substitution, second one is the master theorem, and third one is the recursive tree. So I have already discussed the recurrence relation will come whenever the function is recursive. So to solve the recursive function, first of all we derive the recurrence relation and then we try to solve the recurrence relation. And solution of the recurrence relation basically give us the time complexity of the actual program, or you can say the actual function. So in the previous session we have deal with the substitution method. Now let's see how the master theorem or the recursive tree method is being implemented. Now let's see. So before moving to the master theorem or the recursive tree method, let's try to solve this particular problem. So let's see what is the problem is saying. See, there are four different algorithms A1, A2, A3 and A4 to solve a given problem with the order of log n, log n, n log n and n divided by log n respectively. Which is the best algorithm? So whenever you will say the algorithm is best if it takes minimum time, then you can say the algorithm is best. Now let's see. If I'm assuming n is equal to 2 to the power 16, then the first case, that is the A1 will become log of 2 to the power 16 is equal to 16, and A2 will become log 2 to the power 16 is equal to log 16 and is equal to 4, and A3 will become 2 to the power 16 log of 2 to the power 16. So this one will become 2 to the power 20. Now A4 is given as 2 to the power 16 divided by log of 2 to the power 16. So this one will become 2 to the power 16 divided by 16. So this one will become 2 to the power 12. So the four different algorithm generating four different value: 16, 4, 2 to the power 20 and 2 to the power 12. So of course out of this is deriving the best time and this is deriving the worst time. Are you getting my point? So the right answer for this question will be the A2. The right answer for this question will be the A2. So B will become the right answer. Got it. So in this manner you can easily solve this kind of problem. Already many question has been asked from this particular concept in your GATE exam. So once you will look upon the question of the GATE 2011, you will be able to realize they are asking the like increasing order of the complexity, or you can say the asymptotic notation. So four different complexity, 4 or 5 different functions is given and you have to find out the increasing order of their complexity. So you can easily solve that particular problem. I'm not going to solve all those problems over here, but I'm going to start the next concept that is called the master theorem. So let's start the subject or the topic, that is the master theorem, for which you people are waiting for. See over here. See over here. Master theorem. Okay. See, in the previous session, I have told you that the master theorem is basically applicable to different kind of functions. One is the divide and conquer recurrence relation. Recurrence relation, which we basically represents in this particular format, which we basically represent T of n is equal to Et n by b and plus f of n, where f of n is represented by order of n to the power k, where k, a, b are constant, or you can say the integer constant. Okay, this is the first kind of recurrence relation. This is the first kind of recurrence relation where we basically apply the master theorem. The second kind of recurrence relation is subtract and conquer. Subtract and conquer recurrence. See, this is given by T of n is equal to At n minus b and plus f of, and similarly the a, b and f of n is equal to n to the power k. The same thing will be applied over here. Whatever I have written over here about the f of n and ab, the same thing will apply over here. So this is the subtract and conquer recurrence relation. My dear friends, here you can easily realize we are dividing the value of n by the constant value b every time, and that's why we say it is a divide and conquer. And here we are subtracting some value b from n, and that's why we are saying subtract and conquer recurrence relation. So first of all we will deal with the divide and conquer, and then we will see the subtract and conquer, and we will try to understand the meaning of each and everything. See over here. See, if the recurrence relation, I am dealing with the first part. If the recurrence relation T of n is equal to given as At n by b plus f of n, then the master says this particular part is called the divide time. This particular part is called the divide time. And this is calculated by this particular method, n to the power log of a on the base b. This is calculated with the formula n to the power log of a on the base b. And if you will try to attend my previous lectures, I have given you the proof. why I am writing this. Why I am writing this, I have already given the proof of same in my previous session. So again, if you want, you can check it over here. Suppose I'm taking an example. T of n is equal to, suppose the recurrence relation is given like this: 2t n by 2 and plus. Okay, this recurrence relation is following the form of first master theorem, yes or no? So now this part is basically a divide time. This part is basically representing a divide time. And what is this? This is the n to the power log of 2 on the base 2, and this implies order of n. If you will try to prove this particular thing, suppose we are considering n is equal to 8. Of course, in any algorithm, the n is nothing but the input size of your algorithm. So see what will happen over here. If we are supplying 8, then every time this one will be divided by two equal parts, 4 and 4. So every time whatever the value you will pass in this function, it will be divided into two equal parts, 4 and 4. Again it will be divided into two equal parts, 2 and 2. Again this one is 2 and 2, and again it will be divided 1 1 1 1, similarly 1 1 and 1. So my dear friends, how many recursive call is being made in this particular situation? Of course, here the recursive function will be terminated. Recursive function will be terminated. Are you getting my point or not? Because every recursive function has to terminate. So whenever the single element will be generated, it will be terminated. So how many recursive calls has been made? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So here the number of recursive calls we are making 15. You can write the 15 in this manner: 8 into 2 minus 1. You can write 2n minus 1, and you can write order of n. So the number of recursive call is nothing but a divide time. Number of recursive call is nothing but a divide time. Where what is the meaning of divide time? हर एक बार हम लोग एलिमेंट्स को डिवाइड कर रहे हैं, और तब तक डिवाइड कर रहे हैं जब तक कि सिंगल एलिमेंट जनरेट नहीं हो जाए. दैट इज नथिंग बट अ डिवाइड टाइम. आर यू गेटिंग माय पॉइंट और नॉट? नाउ लेट्स सी हाउ द मास्टर थ्योरम विल बी अप्लाइड. नाउ अब हम लोग देखते हैं एक्चुअल मास्टर थ्योरम को. अभी तक तो ये हो गया लॉजिकल प्रूफ. नाउ सी द मास्टर थ्योरम. मास्टर थ्योरम. See, if the recurrence relation T of n is given as at n by b n plus f of n, then what we will do, first of all we will calculate the u of n, and u of n will be calculated in this form: f of n divided by n to the power log of a on the base b. So what we are doing over here, जो divide time है, और this one is called basically the combined time. This one is called basically the combined time. ठीक है ना? So f of n के वैल्यू को हम लोग इस वाले वैल्यू से डिवाइड कर रहे हैं, तो तीन अलग अलग सिचुएशन होगा. ठीक है ना? या तो ये सभी वैल्यू इक्वल टू 1 होगा, या तो ये वैल्यू लेस देन 1 होगा, और ये वैल्यू ग्रेटर देन 1 होगा. We will have three different options. Either it will become equal to 1, or it will become less than 1, or it will become greater than 1. So we have a three different cases: first case, second case, and third case. So in the three different third cases, the time complexity will be varied. So see over here what will happen. What will happen, please try to analyze over here, then I will tell you the shortcut tricks. Okay, so see here we are deriving the u of n, okay, u of n, and here we are deriving the h of n. So u of n could be what? u of n का जो वैल्यू होगा वो क्या क्या पॉसिबल है, इसके बारे में हम लोग सोच रहे हैं. ये n टू द पावर r पॉसिबल है एंड r लेस देन 0. अगर ऐसा होता है तो h ऑफ n का जो वैल्यू होगा ये हो जाएगा थीटा ऑफ 1, और यू कैन राइट द ऑर्डर ऑफ 1. दूसरा क्या पॉसिबल है, ठीक है ना, log of n to the power I, where I is greater than equal to 0, then it will become theta of log of n to the power I plus 1. And the next thing is n to the power r, where r is greater than 0, then it will become theta of n to the power r. अब इसको रियल एग्जाम्पल से समझने का हम लोग कोशिश करेंगे कि ये मैंने जो यहाँ पर लिखा है इसका सिग्निफिकेंस क्या है, ठीक है ना. वी विल ट्राई टू अंडरस्टैंड दिस विद द रियल एग्जाम्पल. तो देखिए u ऑफ n के तीन अलग अलग वैल्यू पॉसिबल है. दिस इज द फर्स्ट वैल्यू दैट कुड बी पॉसिबल, दिस इज द सेकंड वैल्यू दैट कुड बी पॉसिबल, एंड दिस इज द थर्ड वैल्यू विच कैन बी पॉसिबल. एंड ऑल्सो यू नो, सपोज अगर मैं एक फंक्शन लिख रहा हूँ, समझना बात को, f of n is equal to n square plus n log n and plus 100. तो इस फंक्शन का अपर बाउंड हम लोग क्या लेते हैं, ऑर्डर ऑफ n square. Already you know about this. So if a function is deriving two different value over the input symbol n, then the higher degree term will be considered as a time complexity. These things you already know. और इसी तरह का कुछ फंडा यहाँ पर अप्लाई होने वाला है, तो समझिएगा, ठीक है ना. तो देखिए यहां से हम लोगों ने क्या कैलकुलेट कर लिया, h ऑफ n कैलकुलेट कर लिया. वी हैव कैलकुलेटेड द h ऑफ n. नाउ t ऑफ n विल बिकम ऑर्डर ऑफ n टू द पावर log of a on the base b into h of. Got it? So this one will become the final time complexity. So let's see with the example what this particular things is basically deriving. See over here. See the example number 1. तीनों कंडीशन का एक एक एग्जाम्पल देखते हैं. सपोज रेफरेंस रिलेशन गिवन है, t of n is equal to 2t n by 2 and plus n square. So यहाँ से अगर हम लोग u of n कैलकुलेट करेंगे तो ये क्या होता है, u of n is equal to f of n divided by n to the power log of a on the base b. So this implies n square divided by n to the power log of a 2 on the base b. So this implies n square divided by n, and this implies n to the power 1. So मैंने यहाँ पर क्या बोला था, n to the power अगर r आता है u of n और r greater than 0 होता है, means the third condition will be applied. So here the value of r is greater than 0. So अगर ऐसा होता है तो h of n हमारा क्या होगा, h of n will become n to the power r. This implies are you getting my point or not? Because यहाँ पर r का वैल्यू कितना आ रहा है, 1 आ रहा है. तो अगर आपने h of n कैलकुलेट कर लिया तो t of n क्या होगा, t of n will become order of n to the power log of a on the base b into h of n. So this implies order of n into n, and this implies order of n square. So finally the time complexity of this recurrence relation is order of n square. और ये ऑब्वियस सी बात है, देखिए इतना तामझाम करने की जरूरत नहीं है, मैं आपको एक शॉर्टकट ट्रिक्स बताऊंगा, ठीक है ना. इतना तामझाम करने की जरूरत नहीं है. देखिए करना क्या है, अगर कोई भी रेफरेंस रिलेशन इस फॉर्म में गिवन है, t of n is equal to 2t n बाई बी प्लस एन स्क्वायर। समझना बात को ध्यान से। देखिए मुझे पता है, सॉरी दिस इज द बाई 2, मुझे पता है दिस इज द डिवाइड टाइम एंड विच कुड बी कैलकुलेटेड बाई एन टू द पावर लॉग ए ऑन द बेस बी एंड दिस इज नथिंग बट ऑर्डर ऑफ एन। ठीक है ना, और ये टाइम क्या है, ऑर्डर ऑफ एन स्क्वायर। तो मैंने आपको अभी बोला था कि अगर कोई भी फंक्शन लिखा हुआ है इस तरह के फॉर्म में n प्लस एन स्क्वायर, तो इसका कॉम्प्लेक्सिटी क्या होगा, ऑर्डर ऑफ एन स्क्वायर। सो फाइनली द टाइम कॉम्प्लेक्सिटी ऑफ द रेफरेंस रिलेशन विल बिकम ऑर्डर ऑफ एन स्क्वायर। ब्लाइंडली यू कैन से, आप इस बात को ब्लाइंडली बोल सकते हैं कि इट विल बिकम द ऑर्डर ऑफ एन स्क्वायर, यस और नो। So either you can use the shortcut approach or you can use the entire master theorem, because always the shortcut approach arise whenever you have learned the entire thing very carefully. Got it everyone? So my dear friends, let's see the another example. यहाँ पर हम लोगों ने केस 3 को अप्लाई किया है। किसको अप्लाई किया है, केस 3 को अप्लाई किया है। Now let's see. Let's see the another example. I'm considering the example number. So see over here. Suppose it is given as t of n is equal to 4t n by 2 and plus, समझना बात को। तो हम लोग सबसे पहले कैलकुलेट करेंगे u of n, और u of n क्या होता है, f of n divided by n to the power log of a on the base b. So this implies n divided by n to the power log of a. What is the value of a? 4 on the base 2. So this implies n divided by n square, and this implies n to the power minus 1. So here value of r is less than 0, because we are getting the value of r is equal to minus 1. So if this thing is happening, then what we will do, we will apply the first method. We will apply the first method if the r is less than 0. So here it is the case 1. विजय लाइफ में कुछ सीखने के लिए हर एक चीज सीखना बहुत ही जरूरी है, क्योंकि छोटे छोटे चीजों को सीख करके ही शॉर्टकट फॉर्म या शॉर्टकट ट्रिक्स जनरेट होता है। इफ यू डोंट नो द एंटायर थिंग्स, ठीक है ना, वो फील नहीं आएगा कि किसी भी चीज के पीछे आने का रीजन क्या है। थोड़ा सा पेशेंस रखिए। आर यू गेटिंग माय पॉइंट विजय? यू नीड टू कीप सम पेशेंस। फाइन। सो इफ u of n is this, then already I have told h of n क्या होगा, h of n होगा theta of 1, which is nothing but a constant time, means t of n will become order of, already I have told, n to the power log of a on the base b into h of n. So this is the order of n to the power log of 4 on the base 2 into constant. So it will become n square. So देखिए इतना बड़ा मेथड आपको यूज करने की जरूरत भी नहीं थी। इसका शॉर्टकट ट्रिक्स क्या होगा, देखिए यहां पर अगर कोई भी रेफरेंस रिलेशन इस तरह से गिवन है 4t n by 2 n plus n, already we know from this part we can derive n to the power log of 4 on the base 2. This implies order of n square, and from this part we are getting order of n, and these are in a summation form. So finally it will become order of n square. So it will become the final answer. So you don't need to apply the entire things. Are you getting my point or not? You don't need to apply the entire things. Just looking upon the recurrence relation, you can easily find out the answer. इस पूरे को सॉल्व करने की जरूरत भी नहीं थी, बट ये सीखना जरूरी है. दिस लर्निंग फेज इज नेसेसरी, एंड दैट्स व्हाई आई एम डीलिंग विद दिस. गॉट इट? सो लेट्स सी. अभी तक हम लोगों ने केस 3 देखा, केस 1 देखा. नाउ लेट्स टॉक अबाउट द केस 2. ठीक है, चलिए अब हम लोग एग्जाम्पल नंबर 3 की ओर चलते हैं. सपोज कोई भी रेफरेंस रिलेशन गिवन है इस तरह से, टी एन इज इक्वल टू 2t n by 2 n plus n. आपको याद होगा जब मैंने सब्स्टिट्यूशन मेथड यहां पर अप्लाई किया था तो व्हाट वी हैव फाउंड t of n is equal to order of n log n. Yes or no? When we have applied the substitution method in the same recurrence relation, we got this. So let's see. अब देखो इस वाले पार्ट से क्या डिराइव हो रहा है, इस वाले पार्ट से डिराइव हो रहा है n to the power log of a on the base b. This implies n to the power log of 2 on the base 2 and this implies n. तो यहां पर जब हम लोग u of n कैलकुलेट करेंगे मेरे दोस्त, यहां पर ध्यान से समझना, ये क्या आएगा, n divided by n is equal to 1. You can write the 1 in this manner. Log of n to the power 0 means here the value of I is equal to 0. So h of n क्या होगा, h of n क्या होगा, h of n will become the log of n to the power I plus 1. So it will become log of n to the power 0 plus 1 and it will become log of n. So finally the t of n will become order of n to the power log of a on the base b into h of n. So it will become order of n, will become order of n log n. तो इन शॉर्टकट ट्रिक्स में क्या याद रखना है, ठीक है ना. अब देखिए हम लोग शॉर्टकट ट्रिक्स की बात करते हैं. शॉर्टकट में आपको क्या याद रखना है, बस एक ही सिचुएशन है, एक यही केस 2 का सिचुएशन है जो आपको ध्यान में रखना है. दिस इज द सिचुएशन इनसाइड द केस 2 दैट यू हैव टू रिमेंबर, अदरवाइज दोनों केस इजी है. तो अगर कोई भी रेफरेंस रिलेशन देखिए इस तरह के फॉर्म में है, ठीक है ना, n by b n plus f of n. See, if n to the power log of a on the base b it is greater than f of n, then t of n क्या होगा भाई, t of n will become order of, पूरा का पूरा टाइम कॉम्प्लेक्सिटी इस वाले पार्ट पे डोमिनेट कर जाएगा. इट विल बिकम ऑर्डर ऑफ n to the power log of a on the base b. This is the first thing. Okay, the second situation is if f of n is greater than n to the power log of a on the base b, then t of n will become order of f of n. Okay, now the case 3, if f of n is equal to है log of n to the power I n to the power log of a on the base b. So यहां पर क्या हो सकता है, I could be greater than equal to 0. सो i का वैल्यू अगर 0 होता है तो ये दोनों आपस में बराबर हो जाएंगे. इफ i is equal to 0 then the f of n will become equal to n to the power log of a on the base b, और यहां पर ये log n भी हो सकता है. तो इस सिचुएशन में हम लोग क्या लेंगे, the t of n will become order of n to the power log of a on the base b into log of n to the power I plus, got it, log of n to the power I plus 1. तो देखिए अगर I का वैल्यू 0 है तो ये n log n हो जाएगा, अगर यहां पर I का वैल्यू 1 है तो ये क्या हो जाएगा, n log n स्क्वायर हो जाएगा. टेक अ एग्जाम्पल, see over here. Suppose I am giving you a example number 4. Please try to understand. If it is given as t of n is equal to 2t n by 2 and plus n log n log n. So what we will do? What we will do? We will compare this value with this value. So how you will compare? So this value, that is the n to the power log of a on the base b, sorry, okay. So we will calculate the h of u of n in this manner. Yeah, you don't need to calculate the u of n, you can directly compare, like n log n divided by n to the power log of a on the base b. This implies n log n divided by n. So n will be cancelled out, it will become log of n. So this is the power 1, means this is the I is equal to 1. So if I is equal to 1, what you will do? T of n will become order of n to the power log of a on the base b into log of n to the power I plus 1. So finally it is coming out to be n log of n to the power. Got it everyone? So इस तरह से आप इजीली किसी भी न्यूमेरिकल को सॉल्व कर सकते हो. सो अगर आपको इतना पार्ट याद है, ठीक है ना, और इसको याद भी नहीं करना है. ऑफ कोर्स इफ दिस पार्ट इज ग्रेटर देन दिस, द कॉम्प्लेक्सिटी विल बी डोमिनेटेड ओवर हियर. If this part is greater than this, then the complexity will be dominated over here. Only the thing will be changed whenever the f of n is coming out to be log of n to the power I into n to the power log of a on the base b. In that situation, you have to apply this. Clear everyone? So if it is clear, then I am giving you some of the problem. I am giving you some of the problem. Please try to solve it. Please try to solve it. See, the question is solve the following recurrence relation. Recurrence relation using master theorem. Using master. Okay, the first one is T of n is equal to 8t n by 2 plus square. Second one is T of n is equal to 9t n by 3 and plus square. The third one is Tn is equal to 4t n by 2 plus n square by 100. Fourth one is T of n is equal to t n by 2 plus 1. Fifth one is T of n is equal to 2t n by 2 plus. Sixth one is T of n is equal to t n by 2 and plus the last one, that is the seventh one, is given as T of n is equal to 2t n by 2 plus n by log of. Okay, so these are the recurrence relation which I have given to you. Now you just tell me the answer. So my dear friends, what will be the answer of this question? So you can see over here, from this part what you can derive. n to the power log of 8 on the base 2. So this is greater than n square, yes or no? Because this part will derive n to the power 3. Bolo bhai, this part will derive n to the power 3. So this one is greater than this one. So the complexity will become order of n to the power q. So directly you can answer it. Directly you can answer it. Similarly, from this particular part, what you can derive? From this particular part, you can derive order of n square, and these both are equivalent. These both are equivalent. So in that situation, it will become n to the power log of a on the base b into log of n. So this implies order of n square log of. Got it, everyone? Similarly, just think about it. My dear friend, just see over here. It is given as n square by 100. So if any function is given like this, f of n is equal to, suppose it is given like n square by 10 minus n by 20. What is the upper bound of this? The upper bound of this will become order of n square, because whenever we are calculating the time complexity, then we are always ignore the constant term. And what is the constant term over here? 1 by 10 is the constant term. Similarly, here 1 by 100 is the constant term. So the upper bound of this will become the order of n square. So from this particular part, we are calculating order of n square, and this is also order of n square. So finally, the time complexity of this particular recurrence relation will become order of n square log of. Similarly, just think about the problem number 4, 5 and 6. So see, problem number 4. So from the problem number 4, what you are getting? See, I'm just doing it in a separate sheet. It is given as t of n. This is the problem number 4. T of n is equal to t n by 2 and plus. So from this part, what you will derive? You will derive n to the power log of a on the base b. So this implies n to the power log of a. What is the value of a? 1 on the base b, 2. So this implies n to the power 0, and this implies order of 1. And this is also a order of 1. Means both are equivalent. So if both are equivalent, then t of n will become what? Will become order of n to the power log of a on the base b into log of n to the power I plus 1. Yes or no? So ultimately it will become n to the power 0 and log of n. So ultimately it will become order of log of. So directly here you can see the time complexity of this is order of. Similarly, just think about this problem number 5. Similarly, if you will think about the problem number 5, then it is given as t of n is equal to 2t n by 2 plus 1. So from this part you are deriving n to the power log of 2 on the base 2. This implies order of n, and of course this is greater than constant time. So the complexity will be dominated over here. So finally t of n will become order of. Got it? So ultimately the answer of this question will become order of. And here this part is greater than this, because this part is deriving n to the power 0 and this part is deriving n. So complexity will be dominated over here and it will be a order of. Clear everyone? बोलो भाई. But my dear friends, let's try to think about this particular problem because this is the quite interesting. See, the seventh problem is given as t of n is equal to 2t n by 2 plus n by log of n. Can we apply the master theorem over here? The question is, can we apply master theorem here? Master theorem here. So we cannot apply the master theorem here because see the pattern of this. What I have told you, if this is the function f of n, then it should be in a pattern of order of n to the power k. And it is not following the pattern of the master theorem. So we cannot apply the master theorem over here. So what is the alternate method? We can apply the substitution method. So this problem will be solved by the substitution. My dear friends, already this kind of questions has been asked in your GATE exam. In your GATE exam, or they could ask. So let's see how to solve this kind of problem using the substitution method. See over here. Problem is given as t of n is equal to 2t n by 2 and plus n by log of n. Okay, now substitute this first time. So whenever you will place n by 2 in place of n, what will happen? It will become 2, see over here, 2t n by 2 square. Every instance of n will be replaced by n by 2. So it one will become n by 2 divided by log of n by 2, yes or no? And outside of this is the n divided by log of n. So these things, once you will multiply by 2, it will become 2 square t n by 2 square and plus. Once you will multiply this 2 by this 2 will be cancelled. So it will become n by log of n by 2. And this one will become n by log of n. So these things we are getting in a first substitution. These things we are getting in a first substitution. So similarly in the second substitution, what you will get? You will get 2 to the power 3. You can do it n by 2 to the power 3 n plus n by log of n by 2 square plus n by log of n by 2 and plus n by log of n. These things you will get in a second substitution. Second substitution. Clear? These things you will get in a second substitution. Now let's try to analyze the things. Let's try to analyze the things. In a second substitution, this power is 3. Again, this power is 3. And here the power is starting from the 2. Then 1. And then if nothing is there, you can imagine 2 to the power 0. Got it? So if we are making k minus 1 times substitution. See, in a second time, this power is 3. So at the k minus 1, this power will become k. Yes or no, my dear friends? So you can write it over here that 2 to the power k t n by 2 to the power again k n plus n by log of n to the power k minus 1 and plus n by log of n by 2 to the power k minus 2 and plus up to dot dot dot. This one will become n by log of n by, you can write 2 to the power k minus k, because k minus k will become 0, so it will become log of n. Got it? So these things you are getting after the kth substitution. Now I am taking these things into the next slide and let's try to solve this. Let's try to solve this. See over here. See over. See, if n by 2 to the power k is equal to 1, then already you know the value of k will become log of n. So just replace it over here. So here t of n will become 2 to the power log of n, and t, of course we have considered n by 2 to the power k is equal to 1, so it will become 1, and plus here n is common in all the terms, so we will take the n as a common. So ultimately it is becoming 1 by log of, please try to understand what I am trying to write here. You can write, see, whenever there is written 1 by 2 to the power k minus 1, you can write it 2 divided by 2 to the power k. So same thing I will apply over here. So please try to understand. Here n by 2 to the power k minus 1, so we can write n by 2 to the power k into 2, yes or no, plus again it will be 1 by log of n by 2 to the power k into 2 to the power 2, because it is minus 2. Similarly it will become 1 by log of n by 2 to the power k, we can write into 2 to the power k. So my dear friends, what we have assumed n by 2 to the power k is equal to 1. So everywhere where the n by 2 to the power k is appearing, we can make it 1. All the things we can make it as a 1, yes or no. So ultimately what we can write, please try to understand. Of course this one will become n and this one will become the constant, plus here this is the n, and inside the bracket it will become 1 by log of 2 plus 1 by log of 2 square plus 1 by, similarly you can write log of 2 to the power 3 and plus up to dot dot dot, you can write 1 by log of 2 to the power k. Okay, so ultimately this is the n into c and plus n, and what is the value of log of 2? This is the 1. What is the value of log of 2 square? This is the 1 by 2. What is the value of log of 2 to the power 3? This is the 1 by 3, and plus up to dot dot dot, this one will become 1 by k. So already you know the sum series. Already I have told you in my previous session that 1 plus 1 by 2 plus 1 by 3 plus up to dot 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 1 by n. This sum series is equivalent to log of n. So similarly, if I am writing 1 plus 1 by 2 plus 1 by 3 plus up to dot 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 plus 1 by log of n, means here the number of terms is n, then it is coming out to be log of n. If the number of terms is log of n, then definitely it will come out to be log n, log n, because in this particular part we are mentioning the number of terms. So here the number of terms is log of n, so it will become log n. So similarly, what is the value of k? You have find it out. So the value of k is log of n over here. So this sum series will become what? This is the n into c, and plus this one will become n log n. So the upper bound will become, which one is the higher value? This one is deriving the higher value, so it one will become log. So finally, this is the time complexity of the given recurrence. Clear, everyone? This is the time complexity of the given recurrence relation. Clear, all of you? So if the recurrence relation is given like this, the time complexity will become order of n log n. This is the one of the interesting problem that the GATE might ask. So please remember this kind of concept. Okay, please remember this kind of concept, because in this concept the GATE might ask any kind of problem. So here, since you cannot apply the master theorem, and that's why we are applying the substitution method. Here the substitution method looks a little bit complicated, but once you will do a lot of practice, you will be able to solve all these kind of problem. So don't worry, ठीक है ना? लाइफ में टेंशन नहीं लेना है भाई, मेहनत है तो मेहनत करेंगे, ठीक है ना? और जल्दबाजी नहीं होना चाहिए, ठीक है ना? अगर आप रियली किसी भी प्रॉब्लम को बेहतरीन तरीके से सॉल्व करना चाहते हैं तो सबसे पहले अपने अंदर थोड़ा सा पेशेंस लाइए, सीखने का एक अपने अंदर जुनून लाइए. डेफिनेटली यू वुड बी एबल टू सॉल्व ईच एंड एवरी प्रॉब्लम. ओके, सो तो ये एक प्रॉब्लम था इससे रिलेटेड. नाउ लेट्स सी सम ऑफ द न्यूमेरिकल. अब चलिए इस प्रॉब्लम को देखते हैं. इस प्रॉब्लम में पूछा गया है फाइंड द ऑर्डर ऑफ दिस एल्गोरिथम. कैन एनीवन टेल मी द आंसर? आई एम गिविंग यू अ टाइम ऑफ 1 मिनट, ठीक है ना? और 1 मिनट में आपको ये इस क्वेश्चन का भी आंसर देना है और इस क्वेश्चन का भी आंसर देना है. एनी ऑफ यू प्लीज टेल मी द आंसर. इफ यू आर गेटिंग एनीथिंग देन प्लीज टेल मी द आंसर. देखिए यहां पर t ऑफ n है t n by 2 plus n to the power 1 by 2. See over here, from this part you can derive n to the power log of a on the base b. So this implies n to the power 0 and this implies order of 1. And from this part you are deriving order of root under n. Out of this one is bigger, so the complexity will be dominated to the this. So the entire complexity will be dominated to the this. So the t of n will become order of n to the power 1 by. Got it? So आपको पेन उठाने की भी जरूरत नहीं है. इस तरह के प्रॉब्लम को सॉल्व करने के लिए पेन उठाने की भी आपको जरूरत नहीं है, ठीक है ना? Let's see the next problem. See what the next problem is given. T of n is equal to 8tn by 2 plus qn, where n is greater than 1 and t of n is equal to p if n is equal to 1 and p and q are constant. p और q दोनों constant है. तो यहाँ पर आप देख सकते हो इस पार्ट से क्या डिराइव हो रहा है. You can derive n to the power log of 8 on the base 2. This implies n to the power 3. So of course the right answer will become the n to the power c will become the right answer. Okay? So the nq will be the order of this algorithm. So looking upon the problem, you can easily solve the question if you know each and everything. Got it? Now let's come to the next numerical. Okay. So my dear friends, never forget to use the code IFAR to get the minimum 10% discount. Fine. See over here. There are two different functions is given, f of n and g of n, and they are asking which of the following is correct. Which of the following is correct? See, already I have told you, if you want to compare two different functions, then always assume the value of input size as large as possible. So see, this is the quite interesting problem. So that's why please try to understand. Suppose n is given as 2 to the power 16. So what will be the f of n? This is I am considering the case 1. F of n will become log of n to the power 1 by 2, that is the root under. This implies log of 2 to the power 16 to the power 1 by 2, and this implies 16 to the power 1 by 2, and this implies 4. Similarly, what the value g of n is deriving? G of n will become log n. This implies log 2 to the power 16, and this will derive the value. So in the first situation, we are getting the same value over the input size n is equal to 2 to the power 16. Fine. Now let's try to think over the another value. See over here. See, if n is equal to 2 to the power, we are increasing the value of n. 256. So if you are considering the value of n is equal to 256, then it will become f of n will become root under log of 2 to the power 256. So this implies 256. So this implies, what is the meaning of 256? What is the meaning of 256? This is nothing but 2 to the power 8. So here you can write 2 to the power 8, or you can write 2 to the power 4 into 2 to the power 4, or you can write 2 to the power 4, and this one will become 16. Now similarly, just calculate the value of g of n. So g of n is given as log n. So this implies log 2 to the power 256. So this implies log of 256, and this implies log of 2 to the power 8, and this implies. So my dear friends, from the first function you are getting the value 16, and from the second function you are getting the value 8. Means the f of n always derive, or the asymptotic notation of the f of n will always be greater than g of n. Yes or no? Means for the g of n, the f of n can become the upper bound. This condition is true. But if someone will say that for the f of n, the g of n will become the upper bound. Like if someone is saying like this, for the f of n, the g of n will become the upper bound, this statement is false. So the first statement is given as f of n का upper bound कौन है? यहाँ पर ये bracket है g of n. This is the false statement. g of n का upper bound कौन यहाँ पर दिया हुआ है? f of n. Of course this is the true statement. उसके बाद फिर से क्या दिया हुआ है? g of n का lower bound है f of n. भाई हो ही नहीं सकता ना. f of n का rate of growth g of n से high है, तो f of n g of n का कभी भी lower bound नहीं हो सकता. None of this, ये भी गलत है. तो ये ऑप्शन A, C and D गलत है, तो right answer will be B. So for this question the right answer will become the. Got it everyone? बात समझ में आ रहा है? In this way you have to make some analysis while solving the numerical. If you want to solve this kind of numerical, you have to make the analysis in this way. Clear? Now let's come to the another problem. So ये भी अब एक इंटरेस्टिंग प्रॉब्लम है जो कि प्रोग्राम से रिलेटेड है, समझना बात को, ठीक है ना, ये प्रोग्राम से रिलेटेड प्रॉब्लम है। अब इस प्रॉब्लम को सॉल्व करने के लिए यू हैव टू ड्रॉ अ ट्री। भाई ये बाइनरी ट्री का प्रॉब्लम है। व्हाट विल बी द रेफरेंस रिलेशन ऑफ द कोड गिवन बिलो। ये जो कोड दिया हुआ है, इस कोड का रेफरेंस रिलेशन, कौन सा रेफरेंस रिलेशन सही होगा। तो सबसे पहले तो ये समझना पड़ेगा कि ये कोड एग्जीक्यूट कैसे हो रहा है, ठीक है ना। और कोड को एग्जीक्यूट करने के लिए यू हैव टू कंसीडर अ बाइनरी ट्री, because this is the code of the binary tree. So just see over here, I am considering very small binary tree, ठीक है ना। चलिए अब देखो, अब बाइनरी ट्री है तो हर एक नोड का एड्रेस होगा। सपोज दिस इज द 100, दिस वन इज द 200, 300, 400, 500, 600 and 700. Every node has its own address. अब चलिए फंक्शन p में हम लोग कॉल कर रहे हैं रूट। व्हाट इज द वैल्यू ऑफ रूट? 100। तो ये क्या कर रहा है, सबसे पहले प्रिंट कर रहा है। सबसे पहले क्या कर रहा है, प्रिंट कर रहा है। इट इज प्रिंटिंग द डेटा, जिसको हम लोग डॉटेड लाइन से रिप्रेजेंट कर रहे हैं। आफ्टर दैट इट इज कॉलिंग द सेम फंक्शन रिकर्सिवली। और रिकर्सिव में क्या कॉल कर रहा है, p एरो लेफ्ट सब ट्री। तो लेफ्ट सब ट्री का एड्रेस क्या है भाई, 200। सो इट विल कॉल द p ऑफ 200। सिमिलरली इट विल कॉल द p ऑफ 300, ठीक है ना। अब 200 को कॉल करेंगे तो सबसे पहले 200 का डेटा प्रिंट होगा। तो आप यहाँ पर इमेजिन कर सकते हो, दिस इज द डेटा 2, 3, 5, 7, 6, 8 and 9. So here it will print the 2, here it will print the what, 3, और 3 प्रिंट करने के बाद ये क्या करेगा, अपने लेफ्ट चाइल्ड को कॉल करेगा। तो लेफ्ट चाइल्ड इसका क्या है, तो 400 है। ओके, देन इट विल कॉल द राइट चाइल्ड, सो p ऑफ 500। Similarly it will first of all print, so the 5 will be printed, and then p of left child, that is the 600, and then right child, so p of 700। so इसको कॉल करेंगे तो ये सबसे पहले प्रिंट करेगा, दैट इज द वैल्यू 7, एंड देन इट विल रिटर्न। क्योंकि 400 का लेफ्ट चाइल्ड, वेन एवर यू आर कॉलिंग द लेफ्ट चाइल्ड, इसका अगर आप लेफ्ट चाइल्ड को कॉल करोगे तो यहां पर आप चाहो तो सिचुएशन देख सकते हो। वेन एवर यू विल कॉल द लेफ्ट चाइल्ड, इट विल बिकम p ऑफ null. Why I am considering the null? Because the left child is nothing. So the node will store the null value and it will be terminated. Similarly, it will print the value 6 and it will just call its left child, ठीक है ना, जो कि हमारा क्या आ रहा है, p of null. So again it will be terminated. So my dear friends, here we are trying to analyze how many recursive calls will be made. कितने रिकर्सिव कॉल्स होंगे। यहां पर लेफ्ट चाइल्ड में भी नल आएगा और राइट चाइल्ड में भी p ऑफ क्या आएगा, नल आएगा, ठीक है ना। तो कितने रिकर्सिव कॉल्स हो रहे हैं, 1, 2, 3, 4, 5, 6, 7, अगेन 8, 9, 10, इसी तरह से 11। तो कितने रिकर्सिव कॉल्स होंगे, सो द नंबर ऑफ recursive calls will be 15. You can write the 15 like this, 2 into 8 minus 1, so it will become 2n minus, what is the n over here, n is equal to input size, तो इस बाइनरी ट्री में हम लोगों ने n का वैल्यू कितना कंसीडर किया था, 7 कंसीडर किया था। For this particular binary tree we have considered the value of n is equal to 7 because there are 7 nodes, 1, 2, 3, 4, 5, 6, 7. So if you are considering the value of n is equal to 7, the number of recursive calls you are getting the 15. So either you can write in this manner or you can write in an exact form like this. This one will become 2 into 7 plus 1. So ultimately 2n plus 1. So ultimately order of n. So this program or this particular recursive program will take the time complexity order of n. और इस रिकर्सिव प्रोग्राम में क्या हो रहा है कि अगर हम लोग फंक्शन, समझना बात को, अगर हम लोग रूट वाले फंक्शन को कॉल कर रहे हैं तो ये पूरे ट्री को दो पार्ट में डिवाइड कर रहे हैं, एक तो लेफ्ट सब ट्री एंड द सेकंड वन इज द राइट सब ट्री. आर यू गेटिंग माय पॉइंट और नॉट? और लेफ्ट सब ट्री एंड राइट सब ट्री में नंबर ऑफ एलिमेंट्स कितने हैं? n/2 and n/. So either you can think this manner. So in this situation, what will be the recurrence relation? If you are calling the T of n, it is dividing the entire list into two equal parts, n/2 and n/2. So it will become n/2 and plus again n/2. और हर एक लेवल पे ये एक वैल्यू को प्रिंट कर रहा है. So all these printings will take order of one time. So you can write the order of, so ultimately it will become 2t n/2 plus order of, this one will become the right answer. So either you can think in this manner or you can think the total time complexity order of n aa raha hai. So in that situation, see, A will be the right answer. This can never be a right answer because the time complexity of this recurrence relation is 2 to the power n. The time complexity of this recurrence relation is order of n log n. Already we have learned about the master theorem. And the time complexity of this recurrence relation is again order of 2 to the power. So ये तीनों तो नहीं हो सकता है. So the right answer will become this. So in this manner, you can easily find out the answer of this kind of questions. Got it, everyone? Now let's see the next numerical. Let's see the next numerical. Now this is the one of the easiest numerical which you can directly find out. यहाँ पर देखिए दिया हुआ है t of n is equal to 2t n/2 plus 6n minus 1. Of course, if something like this is given, then this is nothing but equivalent to the order of n. So how you can write the recurrence relation? You can write the recurrence relation like t of n is equal to 2t n/2 and plus order of n. So you know about this. Once you will apply the master theorem, it will become the theta, or you can write the big O notation of n log n. So the right answer will become the C. Similarly, just see this particular question. अब देखिए ये क्वेश्चन थोड़ा सा इंटरेस्टिंग है. यहाँ पर बोला जा रहा है कि f of n is equal to n cube whenever the value of n lies between 0 to 10,000. But if it is a n square otherwise. Otherwise means if n is greater than equal to 10,000. And what I have told you, I have told you the time complexity is always calculated for the higher value of n. हमेशा n के हायर वैल्यू के लिए हम लोग टाइम कॉम्प्लेक्सिटी को जज करते हैं. तो n का हायर वैल्यू इसके बाद ही जनरेट होगा. तो उस सिचुएशन में कॉम्प्लेक्सिटी ये क्या बोल रहा है, कितना होना चाहिए? n स्क्वायर. सो द एक्चुअल टाइम कॉम्प्लेक्सिटी ऑफ दिस फंक्शन विल बिकम ऑर्डर ऑफ n square. Similarly, let's think about the second. G of n is given as n if n is lying between 0 to 100 and n square plus 5n. Otherwise means if n is greater than equal to 100. तो हमेशा इसी के लिए टाइम कॉम्प्लेक्सिटी होता है. So G of n will also be the order of n square. Now you can imagine the time complexity of the f of n and g of n both are equivalent. So either f of n can become the upper bound of this or g of n can become the upper bound of this. So here it is saying, the first option is saying f of n is n cube. F of n is n cube. No. G of n is n cube. No. Order of f of n is same as order of g of n. So this one will become the right answer. This one will become the right answer. Logically or mathematically, if you will think, then all these two options are also correct. See, मैंने आपको पहले भी बताया था, अगर कहीं पर भी दिया हुआ है f of n is equal to bigo of g of n, what does this mathematically represent? That the f of n should be less than equal to c into g of n. So f of n का एक्चुअल वैल्यू क्या हम लोगों ने कैलकुलेट किया है? f of n का एक्चुअल वैल्यू है दिस, और यहां पर क्या दिया हुआ है? इस ऑप्शन में दिया हुआ है f of n is equal to bigo of n cube. This implies the f of n should be less than equal to c into n cube. And what is the value of f of n? N square is less than equal to c into n cube. So this is mathematically correct. This is mathematically correct. Yes or no? So logically you can put both this answer. You can put the both this answer. Got it? You can put the both this answer, but C will be the more appropriate answer. क्लियर है भाई? चलिए, अब ये एक लास्ट न्यूमेरिकल है, लेकिन इन सारे न्यूमेरिकल को करने से पहले लेट्स सी सम अनदर कॉन्सेप्ट. एक छोटा सा कॉन्सेप्ट रह गया है, उसको पहले देख लेते हैं. देखिए, अब देखते हैं मास्टर थ्योरम फॉर subtract and conquer recurrence. See, subtract and conquer recurrence relation क्या होता है? T of n is equal to at n by b, sorry, n minus b, and plus f of find. So this is the take example. Suppose आपको दिया हुआ है t of n is equal to 2t n minus 1 and plus 1. So here a is equal to 2 given है, b is equal to 1 given है, और f of n में given है n to the power 0. ठीक है ना? तो अभी हम लोग मास्टर थ्योरम नहीं लगा रहे हैं, हम लोग सब्स्टिट्यूशन मेथड लगा रहे हैं. ठीक है ना? तो यहां पर जब पहली बार इसको सब्स्टिट्यूट करोगे तो क्या बनेगा? 2t n minus 2 plus 1, and this is the plus 1, and this one will become 2 square t n minus 2 and plus 2 and plus 1. So this is you are getting by the first substitution. So my dear friends, in a first substitution, this power is 2, this is minus 2, and this is starting from the power 1. So इस तरह से अगर हम लोग n टाइम्स सब्स्टिट्यूट करेंगे, कितने टाइम? n टाइम्स करेंगे, तो ये क्या हो जाएगा? 2 to the power n t of n minus n plus 2 to the power n minus 1 plus 2 to the power n minus 2 and plus it will become 2 to the power 0. So finally this one will become 2 to the power n and t of 0 and plus this. So this is nothing but a GP series. ये हमारा क्या है? This is the GP series. और इस GP सीरीज को जब आप सॉल्व करोगे तो it will derive order of 2 to the power n. So finally it will become 2 to the power n into c and plus 2 to the power n. So this implies order of 2 to the power. So finally the time complexity of this recurrence relation is order of 2 to the power and this is the time complexity for the tower of Hanoi. अगर आप लोगों ने डेटा स्ट्रक्चर में पढ़ा होगा टावर ऑफ हैनोई, ठीक है ना, ये गेम है हैनोई। तो ये जो है ये रेफरेंस रिलेशन है टावर ऑफ हैनोई का। दिस इज द रेफरेंस रिलेशन फॉर द टावर ऑफ हैनोई which you basically deal in a like data structure which is a part of game. So हम लोगों ने यहाँ पर इस पर्टिकुलर प्रॉब्लम को हम लोगों ने अभी तक सब्स्टिट्यूशन मेथड से सॉल्व किया। नाउ लेट्स सी हाउ टू अप्लाई द मास्टर थ्योरम। हाउ टू अप्लाई द मास्टर थ्योरम। सी, अगर कोई भी रेफरेंस रिलेशन इस तरह से गिवन है, इसको डायरेक्टली सॉल्व करने का क्या तरीका होगा? n माइनस b प्लस f ऑफ, and already I have told you the f of n would be n to the power k, where a and b are constant. So in this situation the t of n will become order of n to the power k plus 1 if a is equal to, this is the first thing the master theorem says. इसके एग्जाम्पल को देखिए मैं क्यों लिख रहा हूं, उसके एग्जाम्पल को देखिए। मैंने यहां पर क्या बोला है कि अगर a का वैल्यू 1 होता है तो टाइम कॉम्प्लेक्सिटी कितना होगा? ऑर्डर ऑफ n टू द पावर k प्लस 1। सी अ एग्जाम्पल, सपोज, साथ ही साथ एग्जाम्पल को देखते चलोगे तो समझ में आएगा। सपोज रेफरेंस रिलेशन दिया हुआ है t ऑफ n इज इक्वल टू t n माइनस 1 and plus suppose it is given as n. So according to the master theorem, here the value of a is equal to 1 and f of n is given as n to the power 1, means here the value of k is equal to 1. So the t of n in this situation, if a is equal to 1, then what will be the t of n? T of n will become order of n to the power k plus 1. So this implies order of n to the power 1 plus 1. So this implies order of n square. And already you know about this. Reference relation. अगर इसमें हम लोग सब्स्टिट्यूशन भी लगाएंगे तो यही आएगा। चलिए देखते हैं। देखिए दिया हुआ है t of n is equal to t n minus 1 plus n। पहली बार सब्स्टिट्यूट करोगे क्या आएगा? t n minus 2 n plus n minus 1 n plus n। इसी तरह से अगर हम लोग n टाइम्स करेंगे तो ये क्या आएगा? सो इट विल बिकम t of 0, और यू कैन से n minus n 1 plus 2 plus up to dot 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 plus n. So what is the sum of this series? This is the n into n plus 1 divided by 2, and this is the constant value. So these are given in the plus form, so it will become order of n square. So either you are applying the substitution method or you are applying the master theorem, you will get the same result, not a problem at all. And you can see this is the recurrence relation of bubble sort. Okay, now तो ये पहला सिचुएशन था। दूसरा सिचुएशन क्या हो सकता है? ठीक है ना, ये तो हमारा पहला सिचुएशन हो गया। दूसरा सिचुएशन क्या हो सकता है? इट विल बिकम ऑर्डर ऑफ n टू द पावर k if a is less than 1. So my dear friends, let's try to understand the second situation. If I am saying recurrence relation is given like this, अगर a का वैल्यू अगर लेस देन 1 है तो सपोज t of n is equal to 1 by 2 t n minus b, that is the n minus 1 and plus suppose this is given as so जितने बार आप इसको सब्स्टिट्यूट करोगे इसका वैल्यू क्या होता जाएगा, डिक्रीज होता जाएगा. क्या होता जाएगा, डिक्रीज होता जाएगा. ठीक है ना. तो अल्टीमेटली जो कॉम्प्लेक्सिटी है वो पूरा का पूरा दिस पार्ट दैट इज द एफ ऑफ एन वाला पार्ट इसी पे डोमिनेट हो जाएगा. एंड दैट्स व्हाई वी आर सेइंग द एफ ऑफ एन इज इक्वल टू ऑर्डर ऑफ t of n is equal to order of f of n, which is nothing but what we have assumed, n to the power k. Got it? N to the power k. So this is the f of n, and f of n is always represented in the form of n to the power k. So the entire complexity will be dominated over here. Got it? So this is the second rule. The third one is it will become n to the power k and a to the power n by if n is greater than. So only you have to remember this particular part. You have to remember this particular part. So just mark is as a start. Just mark is as a start. So what this thing is saying, take an example. Suppose example number 3 is given as, suppose t of n is equal to, it is given as 2t n minus 1 and plus suppose it is given as n. So here value of a is greater than 1 and this is the value of f of n which is given as n to the power 1. So in this situation the t of n will become order of n to the power k into a to the power n by b. So this one will become order of n to the power 1 into the value of a is 2 n by the value of b is 1. So this one will become order of n into 2 to the power. This one will become the final answer. Similarly, take the next one more example. Suppose t of n is given as 3t n minus 2 and plus n square. So in this situation here the value of a is greater than 1. So the t of n will become order of n to the power k into a to the power n by b. So what is the value of b over here? Please try to understand. The value of b is given as, this is the value of b. The value of a is equal to 3 which is given over here, and this is the value of f of n. So this is nothing but this part. This one will become order of n square into n. What is the value of n? The value of, sorry, a to the power n by b. So the value of a is 3 to the power n by b. The value of b is 2. So you can write order of n square root under 3 to the power. This will become the final. This will become the final answer. So in this way you can solve any question related with the subtract and conquer recurrence relation. Subtract and conquer recurrence relation. So the master theorem is basically applicable for two kind of recurrence relation. One is the divide and conquer and the second one is the subtract and conquer. And you can apply the master theorem at any one of the method. And I have also given you the proof how the master theorem is applied and why the master theorem has derived that particular formula. Okay? किसी भी मास्टर थ्योरम का कोई भी डेरिवेशन कैसे आया इसका भी मैंने आपको एक लॉजिकल प्रूफ दे रखा है. So if you will start from the beginning, you would be able to know each and everything. So my dear friend, that's all for today. आज मैंने पूरा का पूरा मास्टर थ्योरम डिस्कस कर लिया. जितने भी प्रेडिक्टेबल क्वेश्चंस हैं वो सारे मैंने डिस्कस कर लिए. अब आपके लिए एक ही टॉपिक रह जाएगा, दैट इज द रिकर्सिव ट्री मेथड, जो थोड़ा सा इंटरेस्टिंग है. और नेक्स्ट लेक्चर में मैं आपको बताऊंगा रिकर्सिव ट्री मेथड क्या होता है, और न्यूमेरिकल को देख करके आपको समझना पड़ेगा कि आपको वहां पर सब्स्टिट्यूशन अप्लाई करना है या मास्टर अप्लाई करना है या रिकर्सिव ट्री मेथड अप्लाई करना है. So how to analyze the numerical so that you would be able to know which algorithm you should apply. Okay, which theorem or which method you should apply. So that thing I will discuss into the next lecture. So dear friends, if you want to get the subscription, you can use the code IFA to get the minimum 10% discount. Never forget to subscribe this channel. So my dear friend, if you are really liking this video, you can subscribe the channel. You can refer your friend to subscribe this particular channel, क्योंकि जितने ज़्यादा स्टूडेंट यहाँ पर जुड़ेंगे मज़ा उतना ही आएगा, क्योंकि मज़ा हमेशा भीड़ में ही है. क्योंकि आपको जो एग्ज़ाम देना है फाइनली वो भीड़ में ही देना है, अकेला आप एग्ज़ाम नहीं देने वाले. सो जस्ट पास दिस लिंक टू योर फ्रेंड्स, दोज हु आर प्रिपेयरिंग फॉर द गेट like or TIFR or like UGC NET or anything which comes under the like computer science and IT. ठीक है ना, TIFR हो, DRDO हो, NIC हो, ठीक है ना, बार्क हो, इसरो हो, किसी भी चीज का वो, उसको आप इस वीडियो लेक्चर्स को क्या करिए, शेयर करिए, and put your valuable comments, because your one valuable comments will inspire the many other students. And don't forget to press the bell icon button to get all the notification. So thank you very much guys, take care, bye, मस्त रहिए, enjoy करिए, लेकिन मेहनत करते रहिए, क्योंकि मेहनत करने वालों की दोस्तों कभी हार नहीं. बाय ऑल ऑफ यू.